Alright, so today we're going to be working on a MacBook Pro Retina that is not turning on, not charging the battery, not giving a green light in the charger. When I first plug in the charger, you'll see a green light flicker on for a quick second. And by you, I mean me, because I know that with the shitty lighting in this office, there is no way in hell you're going to see that actually flicker. Yeah, who am I kidding there? So, I'm going to plug in a known good DC-in board. I don't trust this person's DC-in board. It's a rainy, shitty day outside. Yeah, I'll show you under the microscope. You have an actual chance of seeing it there. Just turn the light off on the camera. So I plug it in, and you get that. I don't know if you were able to see that. So it turns on off. And then it's done. So let's go over and try to figure out why this is, shall we? So first thing to do here is see if there's anything going on with the current sensing circuit. However, before we even go over current sensing or how current sensing can influence this, let's go over some of the areas that have some corrosion left. This is something that was cleaned with the standard toothbrush and alcohol shit, and you'll get to see just how bad that is. Just adjust the microscope camera so it doesn't look like shit anymore. There we go. Hopefully that tearing stuff is gone and you're seeing a nice fluid 60 frames per second without the the lines and the stuff showing up. So we've got some corrosion around here, and let's take a look at what this thing is for, what it does. And we're also going to talk a little bit about how the charger, how the MagSafe charger works while we're here. So first thing to do here is open up a schematic diagram for the 820-3476. And here we are. Now, what we're looking at over there, I believe, is Q7180. And I say I believe because I don't remember. That's not. That's Q7130. I'm losing it. All right, let's see. So where is Q7180? Oh, wait a second. Yeah, I am losing it. I thought that was a... Okay, so Q7130 is the one with the corrosion around it. So Q7130 is going to be over here. And this is the transistor involved in making PP bus G3 hot. It's the transistor involved in the buck regulator that's making PP bus G3 hot. So first thing I'm going to do here, since this is corroded and it has a direct path to ground, I'm going to check and see if there's a short to ground over here. So let's take a look in that area. I'm going to measure on pin 1 of L7130. And let's see what I get. So L7130, pin 1, and we're going to get over and check, see what we get. So let's see if there's any type of short to ground that could be causing this behavior. Make sure you can see in there. So, nah, that's fine. There's nothing wrong here. I'll just check in a couple of other points that I'm used to being screwed up. Okay, so this one's going to suck. I thought it was Q7180. You know why that sucks? Is because I thought I had a chance of this actually being easy. Nah. Welcome to the videos that never make their way to YouTube, where I have to actually use my brain and figure it out for myself. I don't want to use my brain. Everybody else gets along not using their brain. Why do I have to use mine? Okay. Time for brain. This part sucks. Alright, let's explain how the charger works a little bit here. So, the charger is not going to let power through to the machine unless it sees a load. And if this transistor is not opening, Q7180, it's not going to actually see a load, which means it's going to turn on for a quick millisecond and then turn itself right off, right? So there are a couple of things that could cause this to not open. The ISL 6259 could cause it to not open. It itself could be bad, which could be causing this. If there's corrosion over here, I don't know, maybe something around it got screwed up. So we're just going to check some of the standard things that cause this to happen. Let's see if the current sensing section over here is working the way it's supposed to. Remember, if you don't know what current sensing is, view the videos that I've done on current sensing. It will make all of this make a lot of sense. So this is going to tell how much power the charger is pulling. This chip is going to read the difference in voltage between the top and the bottom. There's going to be a bigger voltage difference depending on, if there's going to be a bigger voltage difference if the computer is using more current, which is how the U7100 will tell. However, if anything in this loop is blown, it's not going to work right. So we're going to check by R7121 and R7122. And I'm going to, let's see, where is current sensing here? Where are you hiding? Okay, this is one of them. I'm measuring the entire circuit here. That's diode mode, though. What the hell? Not diode mode. We want resistance. All right. So this one is probably the battery one because why you? I don't want you to beep. Fuck off. All right. This is probably the battery one. The battery one below is the one that's about 2.2 ohms altogether. Yeah. So see, the battery also has a current sensing circuit attached to it. R7151, R7152, and that's 2.2 plus 0 plus 0.005. All right. So now we're going to check the charger current sensing circuit. It's going to be this one over here. What I'm doing is I'm measuring the entire resistance of the circuit and 20 ohms. All right, so could be a couple of different things. So remember, the green light is present when PP3V42 underscore G3 hot is present, so I'm just going to plug in my MagSafe here and see if PP3V42 underscore G3 hot is present where it's supposed to be. For those of you who don't usually follow these videos, I would suggest you check out my one-wire circuit videos so that you know what I mean when I say that I need PP3V42 to be present in order for me to have a green light. So I'm going to check up here and I'm going to see if PP3V42 is present. It's not present. I have shit. Now I'm going to check to see if I have a short to ground on that particular rail. It's not. No short to ground. All right. So now what I'm going to do is I'm going to check the beginning of the circuit. Hello.
So the price they gave you, this lady from JBC, is actually discounted 10%. Usually that hose set is $320 something. Get the fuck. What?
So do you think I should go for it, or are they being salespeople?
No, I mean, listen, this whole air station is expensive as shit, so just go for it. I mean, fuck it.
I'll go for it.
Unless you want to buy one from eBay.
Fuck no.
All right.
Thank you. Sounds like my JBC is getting fixed. Sounds like Steve's attempts to bargain with JBC have failed. Oh well. $289 for that nozzle though. Like that's $280. I mean, you can buy a hot air station for that much money, but it's worth it. It's a good station. You know, people are like, Lewis, you should ask these companies if they want to sponsor your show. Like, are you kidding me? Are you fucking kidding me? That's not happening in my lifetime. Anyway, back to business here. So now we're going to check the beginning of the PP3V42 circuit. All right, so let's see if I have power coming in here. R7020. So this is going to be the input to this circuit. So the whole idea is I like to check the beginning and the end of a circuit. The reason is if there's a larger problem, I always kind of want to be aware of the larger problem before I continue down the rabbit hole. So if I start going, let me troubleshoot U7090, let me troubleshoot an issue with the PP3V42 generator regulator chip, then if there's a problem before it, I'm never going to know. But the way I'm doing it right now, if there's no power going into U7090, I'm going to figure it out immediately. So plug it in, and we're going to check on our 7020 here. Go back to voltage mode in the meter. Yawn. 0. Spikes and goes down. Spikes and goes down. Spikes and goes down. Now, knowing that the charger is not going to output voltage if it doesn't see a load, maybe it's not seeing the system load because Q70 7180 is blown. Wouldn't it be cool if the actual problem with the board was the problem I thought it was in the beginning? Yeah, let's go with that. Trust you. I trust my instincts. Turn on that Weller. Gonna make sure that I'm really, really patient here because, you know, thing takes forever to actually get hot. Once upon a time, I thought that was the best station ever. I miss my JBC. I have to fix that thing. The JBC kicks the ever-loving shit out of the Hacko and the Weller. I love it. But man, $289 to fix that thing. $289. Yeah, it's worth $289. Yeah, waiting this long is bullshit. Would you like some flux with your flax milk? Hey, my flux ran away. What am I doing? It's fine. Stop soldering, you fuckwit. Ah. My attempt to make it perfect, I'm just making it worse. Alright. This there. And we're going to get a new transistor on there. Looks like some HAL 9000 shit right there. I fucked up by changing all these settings. There we go. HAL 9000. Charging MOSFET. Now, for the ultimate test, we got to make sure that every function on this works. I have to make sure every function works because I'm getting trolled in these videos, you know. Okay, you showed us the light works, but does that mean that everything works? Does that mean that everything is good? How do we know that you're not lying at the end? You're not coming back here and not telling us when stuff doesn't fully work, are you? Well, guess what? How about this right here? I'm going to show you beyond any reasonable doubt that everything on this device works. Ready? Check it out. Check it out. See that? That's a spinning fan, which means we're done. And that's it for today. As always, I hope you learned something. But just to go over, in case you didn't know, these Apple chargers will not give out voltage. They won't give out shit if they don't see a load. If it doesn't see a load for whatever reason, it's not going to work. So it needs to see a load. And if that transistor is blown, it won't see a load. And you just look at the board and you kind of get an idea of where the corrosion was. Then you start thinking about what it could have affected. Then you start looking at your problem. You start comparing, what could have been affected by the spill? What is actually going on? And eventually, your detective brain will lead you to what it is. And that's it for today. This video brought to you by Weller WHA9. No, fuck off. Fuck out of here. I can't wait to get this thing back in the student workstation where it belongs. I miss you, JBC. I miss you. You know how I broke the JBC? I broke the JBC in a really dumb way. So when I'm replacing MacBook Air screens, I use this, and I showed you that I heat this so that as soon as I put the spatula in, I can just go around it and the adhesive just melts right off. Well, I didn't have a nozzle on this because I was removing an iPhone shield as my last job, which is, by the way, why you should never fix iPhones, because if you fix iPhones, it'll cause you to ruin your $1,800 hot air station. So, and I shoved this right up in there, thinking, oh, I'm gonna get it to heat up faster, and I'm touching the heating element, and I'm shorting the heating element to the fucking case like an idiot, which is why I'm now paying the $289 idiot fee to get my JBC back, because I miss it. I don't want to use this anymore. I'm sorry. I know I spoke nice of you months ago, but that thing is just so much better. Especially with this shit, like, you see how long this is? You see how long the hot part is? This is one of the things that I didn't notice until later on, because there's no shield over this. Like, the Hacko at least has that crappy plastic shield over it, right? But this is really thick, really long. This doesn't sound right. It's really thick, it's really long, it's black. Oh, this is just sounding even worse. And there's no recovering from that, is there? And the whole idea here is when I'm heating it, and I have, let's say, I have my tweezers here, and I have this here, this is going to burn my hand. And it sucks. Whereas this JBC one, which is wrapped around my chair and the machine, and a bunch of other stuff, the handpiece is up here. This part is thin, it's closer to the bottom, and it's not that long. So it's less likely to burn you, and it's just I prefer it that way. I like having a lower likelihood of having my hand burned over the course of a repair. That being said, that's it for today, and as always, I hope you learned something, and I hope this was actually in sync